I'm Dr. David Jenkins, a professor of chemistry at the University of Tennessee Knoxville. Today I'd like to tell you a little bit about my research program here. I like to think of my group as a total synthesis group. We do organic, organometallic, and inorganic chemistry. I have two projects today that I'd like to tell you about. The first is a project in homogeneous catalysis. In this case, we make molecular complexes for doing homogeneous catalytic projects. In the second project, we synthesize nanoporous materials. In this case, we use organic synthesis to prepare ligands that are then combined with metals to make a nanostructure. Two of my graduate students will tell you a little bit about each project as well as what it's like to work in my lab.
Hello everyone, my name is Chris and I work on the materials side of Dr. Jenkins Group, the synthesis and characterization of metal organic frameworks, or MOFs. The first step is going to be gaining some valuable synthetic experience by making these organic linkers. So then the next step is we want to use these and actually make the frameworks themselves, so you get a lot of material synthesis experience. The more challenging and exciting part is the characterization of these frameworks. So the first step we always do is single crystal X-ray, where we actually determine the connectivity of these frameworks, and that's very important. Then we can follow this up with, for example, NMR, both solution and solid state, more powder X-ray diffraction, for example, and even gas absorption testing. So overall, the MOF project, it involves a wide variety of skills, such as from organic synthesis to the solid state analysis of these frameworks. And so if you're really wanting to look at designing new frameworks and thinking outside the box and testing different reaction conditions, then the MOF project is for you.
Hey, I'm Alan in the Jenkins Group, and I'm here to tell you a little bit about what we do over on the tetracarbene project. So what you'll find in our lab is that we do a lot of traditional synthetic organometallic chemistry, which means we do a lot of reactions under inert atmosphere. That means that we get to do a lot of things that most people don't get a chance to do, where we work with Schlenk lines and work with glove boxes. To give you a better idea of what we do on the macrocyclic tetracarbene project, what we do is we prepare new strong donor tetracarbene ligands that we then install on metals from all over the periodic table. The reason we want to do this is so that we can do catalysis and with a variety of different transition metals and a variety of different catalytic reactions. For instance, we have taken one of our tetracarbene ligands and installed it on iron, and we still to date are the only people that can do catalytic aziridination, where we combine an organic azide with an aliphatic alkene, where the aliphatic alkene is a tri- or tetrasubstituted alkene. So we're really excited about these results and really going forward with a lot of the catalysis with this really novel ligand that we've developed. I think what you'll find in our group is that you really can touch on just about every area of chemistry, whether it's inorganic chemistry, inert atmosphere reactions, or organic chemistry in ligand design, analytical chemistry with all the different characterization techniques, or even a little bit of physical chemistry with a little bit of DFT calculations. If you have any questions, you should definitely contact Dr. Jenkins, and I'm sure he will be glad to answer anything that you have.